So here's a question about processor speed. How fast can the processor below run? Now, in order to answer this, we need to know how fast each of the individual parts in the processor are. So here we are, 10 nanoseconds for the instruction memory, 5 nanoseconds to read or write the register file, 15 for the ALU, 5 for the sign extension, 20 for the memory, etc., etc. So here's the speed on how long each thing takes. So how fast can the processor run? Well, the answer here is it takes 55 nanoseconds to do the longest path through the processor, which means 18 megahertz. So here's the longest path. It goes from the instruction memory through reading the register file, the ALU, accessing the memory, and then finally writing back to the register file. So that's 10 plus 5 plus 15 plus 20, and then another 5 to write back into the register file. Here's a question about writing state elements. So what state elements in the processor are written to when a branch not equal is executed? So here it's the program counter. So when a branch not equal is executed, we're going to update the program counter with the next PC to go to, the PC we jumped to. You should also keep in mind here the sign extender here, this isn't even a state element. So this doesn't store state, it just takes its input and uses combinational logic to process it. So what state elements are read when a branch not equal is executed? Well, in this case, it's all of the above. So the program counter is read, so we know which branch base address we're going to use. The instruction memory is read, so that we know what offset we can use for our sign extension. And the register file is read, so we know which register to compare to see if they're equal.